Hi, welcome to Pre-Algebra Lesson 10-6, Solve Problems Involving Area of a Circle. In this lesson, we'll be able to solve problems involving the area of the circle. So let's start with explore it. Latoya cut a circle into 8 equal sections and arranged the pieces to form a shape resembling a parallelogram. So she cut the circle into 8 equal sections, hopefully, and then she arranged the pieces like this so that it's almost a parallelogram if these were straight, right? So let's look at some questions here. How is the base length of the new shape, which is this one, base length, related to the circumference of the circle? So if you look at the base over here, it's this part, right? This part is this part, basically. So it is half of the circle, right? So half of the circumference is equal to the base of the parallelogram, or the shape that resembles parallelogram. Okay, part B. How is the height of the new shape related to the radius of the circle? So the height is this part, right? So this part is not exactly the full radius, which is this part, right? But it's like slanted. So that's, yeah, the radius is almost the same as the height of the parallelogram, or like the side of this one. So if we were to cut this part over here and then put it here, then we can see, oh, actually, aren't they the same, right? So then you know how you can cut parallelograms like this into a rectangle. So the height is actually the same with the radius. Yeah, so it looks like when we make the parallelogram into a rectangle, we can see that the height is equal to the radius. Okay, so since this new shape was made from a circle, use the information from the diagram and the formula for the area of the parallelogram, which is A equals BH, to discover the formula for the area of the circle. So parallelogram, we just compare them, right? So half of the circumference, which is circumference, is pi r, 2 pi r, right? 2 pi r. And so half of the circumference is equal to the base. So this is 1/2 of 2 pi r. And then h, the height is the same as radius, right? So then the area should be 1/2 of 2 times pi r times r. So what does that mean? Then that means we have 2 divided by 2, which is 1. So then it's just pi r. And then we have pi r times r, which is just pi r squared. So the area of the circle is actually pi r squared, and this is accurate. So let's look at focus on math practices. Look for relationships. The formula A equals BH can be used to find a good estimate for the area of a cutout diagram. What would happen to this estimate if the circle were cut into 100 sections, 1,000 sections? So as we have done this activity here, if you were to cut it even in a smaller pieces like that, maybe 16 pieces, then it becomes like this, and then like this, like that, like that, like that. And then if we cut it into 100 pieces, it's gonna be like super small. And then if we, and then the angles of the tilted angles over here are gonna be even smaller. And then you're going to have closer and closer to the straight line. And it's gonna be closer and closer to a parallelogram and a rectangle. So the curves are gonna get straighter and straighter by theory, and if you actually do some experiment, you can see that compared to 4 squares, four pieces, like 4 pieces like that, right? Compared to 4 pieces, 6 pieces, 8 pieces are even straighter, right? And then imagine 16 pieces, imagine 30 pieces, 50 pieces, 100 pieces. It's gonna get closer and closer to a straight line. So yes, if you imagine when smaller sections are used, the curves on the basis of the parallelogram of the new shape will straighten out as the sections become thinner. The shape more closely resembles a parallelogram. So the formula for the area would be more accurate in that case. Okay, good. So this is why we have an area of a circle as pi r squared. Okay, so using that, we're going to figure out areas of circles. Let's look at the essential question in this lesson. The essential question we want to think about is how can the area formula for a circle be used to solve problems? So let's look at some problems and see how it could be used. Example 1. Solve problems involving the area of a circle. The floor of a new butterfly conservatory will be a circle with an 18-foot radius. Ooh, that looks cool. The material for the floor will cost $3.95 per square foot. About how much will the floor cost? So when we construct something like this in a circle, we want to figure out how much it costs. And in order to do that, we need to know the area, right? So if the radius is 18 feet, use the formula for the area of a square or of a circle to figure out the area of a circle. And then every square foot, it costs $3.95. So first figure out the area, and we can multiply that by 3.95 and then figure out the total cost. So using the area of a circle, a equals pi r squared, you just plug in r equals 18 into the equation. Pi is about 3.14, and in your calculator you can also find the pi button, okay? And then you can plug in the equation, and it will tell you it's gonna be 1,017.36 square feet. So the area is about 1,018 square feet. And so you can multiply that by 3.95 and you will get the total cost of the floor, which is about $4,021. So as far as pi is concerned, you don't have to worry too much about exact answer. You can say, oh, it's about this much. Okay, let's look at the try it. At a school play, there's a spotlight above the center of the floor that covers a lighted area with a radius of 7 feet. Ooh, now it's the area of the part that's lighted, right? What's the area covered by the spotlight? So if you are in drama or if you're a drama teacher, you might want to figure out the area of the circle that's lighted, right? For performance purposes and for arranging the drama, the theater, right? So the radius is 7. You can plug that into the equation and solve it. So here they approximate pi with 22 over 7. You don't always have to use that. You can use 3.14. So, but here you can do the fraction. Try not to use the calculator. Pause the video and come back when you are done. Okay, are we ready? So let's check the answers. You plug in 7 in the equation. You have 7 squared, which is 49. And then you can simplify this. And then you can multiply 22 by 7. And you have 154. So the area covered by the spotlight is about 154 square feet. Okay, now convince me, if the diameter of the circle is given, diameter, remember, is like the whole length across the circle. How would you find the area? So in order to figure out the area, you need to know the radius square. Radius square is not 2r, which is diameter, right? So r square is not diameter. So you need to figure out r. How do you do that? You divide by 2. That's it. So divide the diameter by 2. Then use the equation to figure out the area. Okay, let's look at example 2. Use area to find the radius and diameter. The athletic department wants to paint the school's mascot logo on the gym locker room wall. So now it's a circle. They start by painting a solid blue circle on the wall. What is the maximum diameter of the logo if only 1 quart of blue paint is used? So 1 quart of blue paint covers this area, 78.5 feet square. So now we already have an area. Remember the equation, we're still using the equation, but the information given are different. So A now is 78.5. You just plug it into A. And then we already know that pi is approximately 3.14. And we're trying to figure out the diameter. What is the maximum diameter? So in order to do that, we need to figure out the radius. So first, figure out the radius. You can divide 3.14 on both sides, and that's about 25. And so r squared is 25, which means you square root both sides. Square root 25 is equal to plus or minus square root 25 is equal to r square root, right? But then only the positive 5 would work because there's no negative 5 for a radius, right? So then it's going to be positive 5. So the radius is 5 feet. Diameter is 2 times 5, which is 10. Okay, let's look at example 3. Use circumference to find the area of a circle. Now we have another circle here with a fence. Ellie needs new grass in the circular pen for her chickens. What is the area of the pen? So we have a pen here that is circular. Use the area of the circle, which is 2 pi r. This C is not for circumference. It stands for the circular pen. The area of the circular pen is, this is circumference. Yeah, wait, what is the area of the pen? So the fencing is the circumference. So the fencing gives you the information of circumference. Yes. So this is the circumference, and you have 2 pi r for circumference. So first, with the given information, circumference is 176 feet. You plug it into the circumference equation first to figure out r, and then it's about 28, right? And then now we're going to use the area equation now that we know r. So there may be multiple steps involved in solving these type of problems. So here we approximate pi with 22/7, or you could do 3.14. You will get about 2,464 square feet for the area. So there are multiple ways you can solve for when given different given information, right? So let's look at try it over here. This should be your last try it. Let's pause the video, see if you can answer by yourself. Come back when you're ready for answers. Okay, are you ready? Let's look at this together. How far away can a person live from a radio station? Here, and here it's broadcast if the sign covers a circular area of 40,000 square miles. So the area over here is covered by the broadcast. And then you want to figure out the farthest person could live from the radio station in the center, right? So that means what is the radius, right? So what is the distance between this house and the broadcast, which would be the radius. So write your answer as a whole number, which means round it up to the whole number, right? So using the area equation, area is equals pi r square. We know the area is 40,000, and we know that pi is approximately 3.14, and we don't know r, and we're trying to figure that out. So divide both sides by pi. 40,000 divided by pi. Let's use if you have a calculator, you could do 40,000 divided by, if you can find the pi in the calculator in my classroom, it's on the bottom third one, and it's yellow. So you press shift and then press the third button on the bottom, and then you will get approximately 12732.39545 for that. And that is r squared. This is r squared. So you have to square this as well. So click square root button, and then square, and then click the answer button, because the answer we just got was this, right? And then you will get r is about 112.8379167 ... So you can round it up to the whole number. If you did it by hand, so that would be about 113 miles. But if you did 40,000 divided by 3.14, then you will probably get a different answer, slightly different answer, which is 12738.8535. But if you square root this answer, you will get about, if you square root 12739, square root 12739, because you round it down, you should still get 112.87. So it should still be about 113 miles. Okay, what circular area is covered by the signal if the circumference is 754 miles? Ooh, now we have a different situation. So the circumference now is 754. So remember, circumference is 2 pi r. And so circumference is 754. You plug that in. That's equal to 2 pi r. So you divide 754 by 2 pi, and that's equal to r. So our radius is about, take out your calculator, 754 divided by parentheses 2 and shift the third button on the bottom, which is your pi, is going to be about 120.0028271. And so the circumference, so the radius is about 120, right? Now we want to find the area. So the area equation, you plug in radius, which is about 120, and then you can square 120, which is 14400 pi, and that's about, so pi times 14400 is about 45238.93421. So it's about 45,239 miles. Okay, there we go. Or you can just write 14,400 pi miles for this one. Okay, so that was our lesson 10-6, solving problems involving area of a circle. So let's review the key concept. You can find the area of the circle using the formula A equals pi r squared. And if you're given various given information, then you can plug it into the equation and solve for it. So that was lesson 10-6, solving problems involving area of a circle. We'll continue with the next lesson in the next video. Bye!